Earth, a small blue dot in the vast sea of space. Since the dawn of human curiosity, we've looked to the night sky and wondered, how far could we go? Beyond the moon, beyond Mars, beyond the faint light of our sun, to the farthest reaches of the solar system and beyond. But here's the question few stop to ask. How long would it actually take us, with the technology we have right now, to reach every planet orbiting our star? The answers will surprise you. They will stretch your imagination and reveal just how immense, how unfathomably vast our cosmic neighborhood truly is. Today, we embark on a journey, planet by planet, exploring the distances, the travel times, and the remarkable history behind humanity's attempts to reach them. Welcome to Spacefile, and this is How Long Would It Take to Reach Every Planet in Our Solar System? Earth, our launch pad to the stars. Every space journey begins here. A small, blue, rocky world orbiting 93 million miles, or 149.6 million kilometers, from the Sun. Our fastest spacecraft, NASA's Parker Solar Probe, travels at speeds of 430,000 miles per hour, or 690,000 kilometers per hour. At that speed, you could circle Earth in less than 4 minutes. And yet, even this incredible velocity is barely enough to scratch the surface of the distances we're about to face. The farther we travel from home, the more we confront the scale of space and the limits of human technology. First stop, Mercury, the smallest planet and the closest to the Sun. Despite its proximity, about 48 million miles, 77 million kilometers from Earth at its closest, Mercury is surprisingly difficult to reach. A spacecraft must slow down significantly to avoid being pulled too deep into the Sun's gravity well. Surface temperatures swing wildly here, from scorching daytime highs of 800 degrees Fahrenheit or 430 degrees Celsius, to frigid nighttime lows near minus 290 degrees Fahrenheit or minus 180 degrees Celsius. It is a world of brutal extremes. Our first encounter came in 1974, when NASA's Mariner 10 performed 3 flybys, arriving just 147 days after launch. But orbiting Mercury is far more challenging. ESA's Bepi Colombo, launched in 2018, will take 7 years, arriving in 2025 after a complex series of gravity assists. At Parker Solar Probe's record speed, a spacecraft could reach Mercury in just 15 days. But stopping to orbit and survive is another matter entirely, due to the Sun's close proximity. Next, we turn to Venus, often called Earth's twin. It's covered with sulfuric clouds and volcanic plains beneath a thick orange atmosphere. It's similar in size and composition, yet utterly alien in reality. Its thick carbon dioxide atmosphere creates a runaway greenhouse effect, heating the surface to 860 degrees Fahrenheit, 460 degrees Celsius, hot enough to melt lead, also hotter than Mercury, despite being farther from the Sun. At its closest, Venus is just 26 million miles, 42 million kilometers, from Earth, making it one of the fastest destinations in the solar system. The Soviet Venera 1 was the first probe sent toward Venus in 1961, and in 1970, Venera 7 became the first spacecraft to land on another planet. surviving the planet's crushing pressure and intense heat for 23 minutes. Plains on Venus are large areas of relatively flat topography. Over 1,100 volcanic structures over 20 kilometers in diameter have been identified on Venus. Most missions take 4 to 5 months to reach Venus. NASA's Magellan arrived in about 4 months in 1989. A direct high-speed trajectory could cut that to just 40 days. But again, orbital mechanics, the position of Venus, not just velocity, set the pace. Welcome to Mars, humanity's next frontier. Red desert plains, dust storms, robotic rovers. For centuries, Mars has captivated human imagination, a rust-colored world once thought to harbor alien civilizations. Today, it's seen as humanity's most realistic future home. Mars lies about 34 million miles, 54.6 million kilometers, away at its closest approach. With a thin carbon dioxide atmosphere, frigid surface temperatures averaging -80 degrees Fahrenheit, -62 degrees Celsius, and dust storms that can cover the planet for weeks, it's a harsh but intriguing destination. Our first successful flyby was Mariner 4 in 1965. Since then, dozens of missions, including Viking, Spirit, Curiosity, and Perseverance, have revealed a planet once shaped by water and possibly long ago by life. Most missions take 6 to 9 months using efficient transfer orbits. If a spacecraft could match the speed of the New Horizons probe, which reached 36,000 miles per hour, 58,000 kilometers per hour, during its mission to Pluto, it could reach Mars in as little as 38 days, contingent on planetary alignment. NASA estimates future crewed missions will take about 7 months. A daunting journey, but one well within our reach. Beyond Mars and the asteroid belt lies the realm of giants. Jupiter, king of the planets. Massive swirling clouds, lightning storms, and the Great Red Spot. Jupiter, the largest planet in the solar system, is a gas giant over 318 times the mass of Earth. Its immense gravity shapes the architecture of the solar system itself. At its closest, Jupiter is 365 million miles, 588 million kilometers from Earth. Its upper atmosphere is a tempestuous world of hydrogen and helium, home to the Great Red Spot, a storm larger than Earth that has raged for centuries. Pioneer 10 was the first spacecraft to visit Jupiter in 1973, arriving in 21 months. Voyager 1 arrived in 18 months, while Galileo, which entered orbit in 1995, took 6 years with gravity assists. Upcoming missions, like Europa Clipper, will take about 5.5 years. At maximum speed, a direct flight could reach Jupiter in about 4 months. But once again, braking for orbit is the ultimate challenge. And Jupiter isn't just a planet, it's a miniature solar system of 95 moons, including Europa, which may hide a vast subsurface ocean capable of supporting life. Further out, Saturn, the Lord of the Rings. As of March 2025, there are 274 moons of Saturn. Titan is Saturn's largest moon, and the only moon in our solar system known to have a substantial atmosphere. Titan is the only place besides Earth known to have liquids on its surface. It has clouds, rain, rivers, lakes, and seas of liquid hydrocarbons like methane and ethane. Titan is larger than the planet Mercury, Saturn, a gas giant wrapped in one of nature's most stunning displays, its vast system of rings. Made of ice and rock particles, some as small as grains of sand, they stretch over 175,000 miles, 282,000 kilometers from the planet's center. Saturn sits about 746 million miles, 1.2 billion kilometers from Earth. Despite its beauty, it's a world of harsh conditions, with upper atmospheric temperatures near minus 288 degrees Fahrenheit, minus 178 degrees Celsius, and fierce winds over 1,100 miles per hour. Pioneer 11 became the first spacecraft to fly by Saturn in 1979, taking 6.5 years. The legendary Cassini mission, launched in 1997, reached orbit in 6 years and 9 months, revealing moons like Enceladus, venting water-rich plumes into space, and Titan, with its methane seas and prebiotic chemistry. Even at top speed, a direct mission would take close to a year. But patience pays off. Saturn's system is one of the richest targets for exploration in the solar system. Uranus, the sideways ice giant. At the edge of visibility lies Uranus, an ice giant unlike any other. Composed largely of water, ammonia, and methane, it has an atmosphere that glows blue-green and a rotation tilted 98 degrees, rolling around the Sun on its side. Uranus orbits about 1.6 billion miles, 2.6 billion kilometers from Earth, where temperatures average minus 353 degrees Fahrenheit, minus 214 degrees Celsius. Discovered in 1781 by William Herschel, it was the first planet identified with a telescope, expanding humanity's view of the solar system. Only one spacecraft has ever visited, Voyager 2, which flew by in 1986, 8 years and 5 months after launch. It revealed 11 new moons, faint rings, and a magnetic field unlike any other. With today's propulsion, a mission would take roughly 8 to 10 years. A direct high-speed approach could cut that to about 3 years, but none are planned, leaving Uranus one of the least explored worlds in our solar system. Neptune, the distant frontier. Voyager 2 approaches Neptune's deep blue atmosphere and Triton's geysers. Our final planetary destination is Neptune, a remote ice giant orbiting 2.7 billion miles, 4.3 billion kilometers from Earth. It is the windiest planet, with jet streams roaring at 1,300 miles per hour, 2,100 kilometers per hour, and an internal heat source that radiates more energy than it receives from the Sun. Neptune was first predicted by mathematicians in 1846, its existence inferred from Uranus's orbit before it was ever seen. Only Voyager 2 has visited, arriving in 1989, 12 years after launch. It revealed Neptune's violent weather, faint rings, and Triton, a captured moon with geysers blasting nitrogen into space. Future missions would take 10 to 12 years to reach Neptune. Even at Parker Solar Probe's speed, it would require at least 8 months, a testament to the staggering distances involved. The infinite road ahead, from the searing surface of Mercury to the frozen winds of Neptune, the solar system is larger, more complex, and more humbling than we ever imagined. Each mission takes years, sometimes decades, but every journey teaches us more about the cosmos and about ourselves. The distances are vast, the obstacles immense, but our determination to explore is greater still. One day, we may not just send probes, we will go ourselves, carrying with us the story of life from a small blue world orbiting a yellow star. Until then, we continue to reach one planet, one mission, and one discovery at a time. Thank you for watching Spacefile. Subscribe and join us as we explore the universe, one discovery at a time.